Now let's complexify things just a little bit. So I'm sure if you're looking at this figure for the first time, you're probably thinking, oh my God, what is this? And what are we going to do with this? It's probably a little bit confusing to you. Now, the goal here is not to confuse you, of course. It's just to allow you to get used to what's coming next. And it doesn't mean it's complicated. As long as you follow a certain pathway, as long as you know what you're doing and what we're talking about here. So what I want to show here and what I want to explain is that glucose, when we want to create energy from the oxidation process, glucose is a perfect molecule to extract energy from. And your brain right now, while listening to this and maybe worrying a little bit, is using glucose, a huge amount of glucose. And what I want to show here is just how to look at this graph. So what we will see here is the start of the oxidation process of glucose. So it would start right here, and we have our glucose molecule here. And I want to show you something here. When we look at this molecule, we can see that there are 1, 2, 3, 4, 5, and then 6 carbons in this molecule, right? So we have 1, 2, 3, 4, 5, 6. So this is a C6 molecule because it has 6 carbons in this molecule. Now, as we move on to the following steps, because glucose oxidation is a stepwise process. It goes one step at a time, and every single time, for every single step, there is an enzyme that will allow this process to go forward, because each of those reactions are not they're not spontaneous reaction. We need to have enzymes that will allow these reactions to go. And what we have here, the HK here, is the name of the enzyme, and it's called the hexokinase. No need to remember this for now. So as we move on from one molecule to the other, so from glucose to G6, glucose 6-phosphate, so we still have 1 carbon, 2, 3, 4, 5, and then 6 carbons, right? So we still have a C6 molecule here. And as we move on from step 1, 2, 3, 4, 5, there is a point where this C6 molecule here that was glucose will be split into 2 C3 molecules, and this is what we see here, right? So this process, there will be an enzyme here that will split the C6 molecule into 2 C3 molecules, or 3 carbons, and let's count them here. So we have 1, 2, and 3 right here, and there's a 1, 2, and 3 carbons. So our carbons, we have a C3 molecule here, and we have a C3 molecule here as well. So our carbons are conserved here. Now, as we move on, and let's look at this. As we move on, we will notice that this C3 molecule here, so this is a C3 molecule, will move on to become at the end a C2 molecule. We have here C2, right? So pyruvate is C2 molecule. So at some point right here, this step number 8, there is a point where we go to 1, 2, 3 carbon into 1 and 2 carbon. So what happens here is that in order to go from a C3 molecule to a C2 molecule, so C3 to C2 molecule, there is a point where we needed to lose an electron here, right? Because there is a link that was broken, and that link that was broken, electrons follow, right? So the electrons were ejected from that molecule here, and that allowed us to have a C2 carbon here. So you see, what I want to show here is that in this figure, we move from glucose being a C6 to pyruvate being a C2 molecule. And this is done through the oxidation process. So what happens here, because we are losing an electron, losing electron, remember that's the oxidation when we're losing electrons.